Well, my name's Greg Michaelson. I am one of the co-founders at Zerve. But in my life before that, I was at a company called DataRobot. Has anybody heard of DataRobot at all? Yeah? Awesome. Good things or bad things? Good things. Good things. All right, that's fantastic. It was a wild ride. I joined when there were about 30 folks there. And I left, there were probably 1,500. And I was the chief customer officer there. It was exciting to see the business grow like that. The last real project that I worked on was for the US government. And we were working for Health and Human Services in 2020 on the pandemic stuff, which was really interesting because it turned out to be surprisingly political. Who would have guessed that data science would be political? I guess anybody that thinks about it would, I suppose. But we were working with the vaccine manufacturers to try and forecast the spread of COVID. And it turns out that's a surprisingly difficult thing to do. In fact, CDC came out right before we started working with them and said, it's impossible, we can't do it, we're not even going to try. Which was an interesting thing to hear them say. But at DataRobot, what we did is we put 100 engineers on the project. And if you know anything about DataRobot, we invented automated machine learning. Which is building models. Anybody can do it. Your grandma can be a data scientist, that kind of thing. And so we started trying to forecast the spread of COVID and suddenly find out that we can't use our software at all because it's kind of an unusual problem. This was, the 2010s was kind of the time of low code, no code. And I think everybody has sort of realized that the emperor's got no clothes on that kind of stuff because anytime the problem gets unusual or you wander off the happy path, none of that low-code, no-code stuff works anymore. And that's what we found at DataRobot. We literally had to put 100 engineers on this project, and we coded everything from scratch. We couldn't use DataRobot for it at all, which is crazy. We ended up selling the forecasting machine that we built to the US government for $20 million, which was awesome. It was a subscription, so $20 million a year, which was really, really cool. But then Trump got voted out, Biden came in, and Biden canceled every software contract that Trump signed into law, or signed. Every one, except one. Can anybody guess who got to stay? Microsoft. Nope. Trump didn't sign a Microsoft one as far as I know. It predated him. Palantir, it was Palantir. Yeah, what's that? Oh, it probably just went to sleep. I'll wake it up here in a second. Yeah. If I was a professional presenter, I would make it where my laptop wouldn't fall asleep. But alas, no such luck. Yeah. So anyway, it was a wild ride. The particular project we were working on was trying to forecast the spread of COVID 6 weeks out on a daily basis at the county level in the US. So there's thousands of counties in the US. It was a wild, wild project. The point of doing it was that, I don't know if you've ever been involved in a vaccine trial, but what you need when you're doing a vaccine trial is lots and lots of people who are getting exposed to the virus, right? So you could never do an Ebola vaccine trial in New York City. Nobody's being exposed to Ebola in New York City. But with a vaccine trial, you have a test group and a control group, and you give the test group the vaccine and you give the control group nothing, and then you compare who gets sick more. And as soon as you can measure a big enough distance between those two groups, then you can say, the vaccine works. Everybody's happy, and then we can release it. So that's what we were trying to do. We were trying to find the places to send the recruiters to get people to participate in the trials so that people would get sick faster in the trials, and you could measure that statistically significant difference better, more quickly. So we think we actually shaved 6 to 8 weeks off of the trial. But the big thing that I learned during that whole experience was that the tech stack for building AI really sucks. So we had to, for example, one project we were working on was a simulation, and we were in Jupyter Notebooks. How many of you use Jupyter Notebooks? All right, my people. Okay, everybody in this room, which is fantastic. So here we are. I've got a team. I've got a guy in Austria. I've got a guy in Singapore. I've got a guy in India. I've got me in the US, and we're trying to follow the sun because literally thousands of people a day are dying. And so we have this feeling that if we can just get our work done a little bit sooner, maybe we can save people. There's this real feeling, maybe, looking back, it's a little silly. But at the time, there was this big sense of urgency to get the work done as fast as we possibly could. And so here we are with Jupyter Notebooks, which 90% of Jupyter notebooks run locally, right? So we've got all this crazy data from all the states running. I gotta keep this thing going here. There we go. And the states are insane the way that they were recording the COVID data. So like New Jersey, for example, would decide on a fairly regular basis to reclassify deaths as COVID related. And so what date would they use for those deaths? What date would you use? The date that the person died on, right? Not them. They use the reclassification date. So if you look at New Jersey, you see these massive spikes of death where like it looks like thousands of people are dying, but really they've just gone through and cleaned the data, and they're using the date that they cleaned the data as the date of the death, which is insane. And all the states were unique, and they all did crazy things. And here we are in Jupyter notebooks trying to follow the sun and pass these notebooks around. But of course, Jupyter notebooks run locally, and so your results live in memory. And so every time your browser crashes, you have to rerun the whole simulation. And if you want to send it to somebody, then everybody's working off of different environments. So you might be on NumPy 0.19, and I might be on 0.23, and just getting somebody's notebook to run with the same folder structure and everything, it's a nightmare, right? So we go, okay, can we set up like some kind of a Jupyter server or something? Oh, that's too complicated. We can't figure that out. And so anyway, it's a mess, right? And so, that project was fun, learned a lot, did a lot of really fun things. And like I said, 6 to 8 weeks, which was great. But when I left DataRobot, I knew that the stack needed overhauled, because with as many AI and data science projects that people are building, why wasn't there an application for the coders who are interacting with data using code to actually do something end to end in a real way? And so that's why we started Zerve. I met these two Irish guys who had sort of the same idea. They actually reached out to me on LinkedIn, cold LinkedIn email. Our CEO, one of the other two co-founders, is a sales guy, right? Any sales guys here? Okay, good. I can talk shit about sales guys. Okay, awesome. So he has one skill, and it's being a LinkedIn operator. Like he'll get on there and he can get responses. That's like one of the things he's really, really good at. He's good at many things, but LinkedIn. So he messaged me on LinkedIn. He says, "You're not going to answer this, but we think the DataRobot marketing stuff is BS." And he wanted to fight about it. Like he wanted to pick a fight, because they had this view, the same view I had, that the only people that were actually generating value from data were the coders, the experts, the people who actually knew what they were doing. And I 100% agreed with him. And so I flew out to Ireland. I became an advisor for a bit, and then came on as co-founder, and we figured out what product it is that we wanted to build and what we wanted to do. So I thought what I would do today, that's all by way of introduction. 10 minutes left? Really?
10 minutes for talking and then 10 minutes after.
Oh, gotcha. Okay. I was like, wow, I blew through 30 minutes already.
Use up all the time.
No, that's totally okay. You just caught me by surprise. All right. So I thought what I'd do today is just kind of show you kind of how we think about how AI development should be done. Not as a way to sell you something, because we have like a community tier where you can get on and use it for free if you want to, but also as a way to kind of have a little dialogue about what kind of tools you use and sort of where you're coming from and how you see all this stuff working. Because we really see this as the way to have all the benefits of notebooks, right? All the interactivity and the ability to work with your data, kind of built for data, but then also all the stability of an environment like VS Code with all the cloud orchestration and stuff that goes on top of that, so that you can actually ship software instead of building prototypes, which is really all you can do in a notebook. So by way of a use case, what I decided to use here is a call center. So I created a fictional call center for a bank where they're receiving phone calls. And the phone calls are, the things that you might expect, right? Like I need to check my balance, or I don't recognize this transaction, or whatever it might be. Of course, the problem that I had is that I didn't have any recordings of call center transcripts. So I invented some. Large language models are awesome. And so this is like, every time I breathe, should I move it or what? It's very distracting. Here, I'm gonna move it over here. How's that? Can you guys still hear me? Awesome. Okay. So what I did here is I simulated call center conversations, and then I transcribed them and analyzed them here using this little project here as a way to kind of just show how we think about development using a platform like Zerve. So here I started out with with just creating the call center agents. In this case, there's 9 of them. They happen to correspond to the 9 names of the voices from the OpenAI text-to-speech model. And so I just named them the same thing. And then I asked O1, in this case, ChatGPT, to come up with descriptions of strengths and weaknesses for these hypothetical call center agents. And so this is all in the service of like simulating some synthetic data to do this project on. And I think it's cool. So I asked them to make 2 of them to be very bad at their jobs. And so hopefully we can find who those 2 are at the end of our analysis. And that'll give us some confidence that the large language models are actually doing something interesting. So the way Zerve works is that each block here, each block has its own kind of environment, its own kernel that it runs in, and they operate serverlessly. So when I execute this particular block of code, in this case, it's using Lambdas because this is running in AWS. So it'll spin up serverless compute, it'll execute the code, and then it takes the variables, the data that gets created, the models or any variables that you have, and it serializes them, caches them, and stores them on disk, and then passes them downstream to subsequent blocks. Okay? So we're not operating in memory anymore. So this is not like a notebook where if your browser crashes, you lose everything, or where if you want to share it with somebody, then you have to send them a file and they have to figure out all the dependencies and folder structures and all that kind of stuff. Here, it's much more like a Google Docs kind of thing. So I could invite anybody here, Alan, anybody into here to this project, and you'd see their little icon appear, and you could see their cursor moving, and you could see them typing, and they could run code, and you could run code. And so it's a collaborative environment where you can do that. But each block is preserving the artifacts of the analysis. So if you train up a random forest, or if you build a data set, those are serialized and stored somewhere so that you can use them. And it turns out that gives you a lot of really interesting benefits, and we'll see those kind of along the way. So first I generate these agents, and then I want to make some recordings. And so I want to make these recordings as interesting as I possibly can. And so I simulated a data set of average hold times. And then I'm asking the large language models, I'm using a bunch of them. So this one uses O1, this guy's using Anthropic. We've got a Bedrock integration, so we're reaching out to Bedrock and using a bunch of models there. So this gives me a hold time for the call. This selects the agent who's going to actually answer the call. And then I ask for the topic. What's the topic of the call? And what is the description of the caller? Things like ethnicity and social status and all the kind of things that you might want to know. And then I feed that all to another large language model. This is O1 again. I like O1. ChatGPT smokes everybody in terms of the capability and functioning of their models. So I generally prefer them. This is O1. You can pick whatever model you want, though. There's lots and lots of them to choose from. So lots to see. And then so then I ask it to generate the script, and then I turn. I should point out here that I want to generate 50 of these. So I'm going to do 50 per day. And I've got this scheduled so that it'll run every day and generate 50 more calls. But this would be really slow if I was doing it one at a time, right? Because you ask ChatGPT, you're sending 4 prompts out to get like hold times and topics and all that kind of stuff, and then you're feeding that to another one, and the ChatGPT is slow, so it might take 2 hours or something to churn through 50 of these guys. But because of the way we've got this thing structured, each block is running independently. And so I can run as many of them simultaneously as I want. And so we have this thing that's called the fleet. And in this case, you trigger the fleet by using the spread function. And spread just says, here, I'm going to pass you a list. In this case, I'm just passing it 0 through 50. And I want you to take everything after it, and I want you to run all of that stuff all at the same time. So instead of simulating one call and converting that into an audio file, I'm doing 50 simultaneously. The nice thing about that is that it doesn't cost me any extra money in terms of compute, because it's the same compute. It's just saving me wall time because I can do 50 at once. And I don't have to worry about like managing worker pools or setting up like multiprocessing or memory consumption or cores, or I don't have to worry about any of that because it's spinning up separate serverless functions for every step in this process. And so you can see here's my transcripts. If I go to this one that's actually coming up with the transcripts on this side. And here are all the runs. So all 50 of those calls will come up here, and I can actually see what was generated in each of those runs, and that saves me tons of time. So this particular block ran in 14 seconds, all 50 calls to generate all those scripts ran in 14 seconds. And then I'm converting it here to an audio files, and then I'm saving those audio files, and I'm actually storing them out in the file system. So now I have lots and lots of audio files that are named according to the topic of the file, based on what the large language models think about the transcript that was created. So those are there, and then I can start doing some analysis. So, well, first I convert them back to text. So I use Whisper to convert the audio in the audio files back to text, again using OpenAI. And then I want to do some analysis to actually see what's going on here. So I read those transcripts back in from Snowflake, so there's an integration there. It's really easy to work with Snowflake. Now, one of the benefits of the way we serialize the data is that you get language interoperability. So, like for example, a data frame, Pandas data frame would be serialized as a Parquet file, and R knows how to deal with Parquet, and SQL knows how to deal with Parquet. And you could say the same thing for any other data type that you could come up with. So all of a sudden here, like if you look down here at the end, I'm visualizing this particular thing using both Python and R simultaneously, like interchangeably. And so that's one of the big benefits of being able to do it this way, is that I get language interoperability. So I can SQL query a Pandas data frame. I could visualize a Python data structure with ggplot and R, say. And so if I have a multidisciplinary team, they can all be in this canvas, all working together, all doing the same stuff. And I've got the ability to do it in Python or R and so on. And of course, it integrates with like GitHub and Bitbucket and all that stuff. So I could do code control. If you've ever tried to manage a Jupyter notebook using GitHub, it's a nightmare, right? Because every time you open it, the metadata changes and you get all these merge conflicts, and like it becomes impossible to unwieldy to do that. So anyway, this is really nice because when I sync it with GitHub, every block in this particular in this canvas is represented by a file, and then the metadata is stored separately and so on. So I can go out to GitHub here, and I can like create pull requests and do merges and handle conflicts and look at diffs and all that kind of stuff, so that all of my work from the SQL to pull the data out of, say, Snowflake or Databricks or whatever, through to the the statistical analysis that the old codgers use to do their work, and then the Python and all that. It's all done. It's all easy. And the other thing about these blocks is that because they're independent, it's really easy to choose my own compute. So I can select what compute to use on an individual per block basis. So if I go in and look at compute settings, then I might want to use lambdas. I might want to, maybe I need some more memory. I could use a Fargate container. I can spin up GPUs and use SageMaker images, that kind of stuff. And so it becomes really easy to kind of go down that road. Is that 5 minutes for real or 5 minutes?
5 minutes.
5 minutes leaving 10 minutes?
For more, 10 minutes more.
Gotcha. Awesome. Awesome. Okay, so I can select my own compute, and that's really good because really on normal projects, what you end up doing is you choose the biggest compute that you need for any particular step in your project. So if you need a big beefy machine to do your GPUs, then you're stuck using that big beefy machine for the whole shebang. But here I can use the least necessary compute for each individual step, and it can be much more cost effective that way. So here I do a couple of interesting things. I'll point out one. Here I was interested in compliance violations. I don't know anything about call centers, but I think it's a cool use case. So I just told the large language model, I was like, hey, look for compliance violations. I didn't explain what they were. The models are so good. It's so awesome. In this case, it happened to find one, which it wrote out to Snowflake. The agent forgot to verify the account before giving out account details. So who knows? Large language model found that. Once I'm done with that, then I start thinking about deployment. So there's lots of really interesting things you want to do here. This is not just a development environment. It's not just kind of like a place where you can write code and have a little playground, but it's end to end, right? So the development layers are what we've been looking at, scheduled jobs we talked about, but it's really also straightforward to create APIs or to deploy via SageMaker. In this particular case, I'm looking at the compliance stuff. And the way that you structure it here is by creating this API controller block. And then you just add routes to it. So in this case, there's a post route here that's unfinished. I didn't attach any code to it yet. And then there's a get block here. And this get method, or get route, here just goes out and queries what all the compliance issues are. Right? And so here I've got a functioning API. It's already deployed. It's served using Lambdas. But if I don't want to deploy it in Zerve, I can just download it. And so I get like a Docker container, all the Kubernetes setup files. I'd get the fast API docs. I'd get all the stuff that I need to support that, the source code, obviously, to have that deployed somewhere else. And that's super important because, not everybody's going to want to come and work in a different environment. Some people have spent millions of dollars building up their own sort of CI/CD pipelines and all that kind of stuff. And so you want to have the capability to kind of take your ball and go home if you need to deploy it in a different way. But this is super empowering for data scientists because as a data scientist, I know that I wouldn't be able to code up an API like this from scratch by myself. Like I've never done that before. I've never spun up a server that could host it. I've never, I don't know how to do that stuff. It's outside my skill set. But here, I don't have to, right? So we handle all the orchestration and all the load balancing and all the availability stuff so that when you actually go down that road, it's a really easy thing to kind of support and use. A couple of sneak previews, and then I'll stop talking and we'll do questions because I know everybody's excited to move on to something else. In a few weeks, we're releasing our AI agent, which will write code for you. So stay tuned for that. I can go in here and say, look, there's a data set here, and I want you to do this, and it'll go out and it'll look at the data, and it will create the blocks and write the code, and then execute and test the code for you, prompting you along the way and telling you, okay, here's my plan, this is what I'm going to do, should I proceed, that kind of thing. So it's a super powerful, really fun thing to work with. In fact, I started playing with one this morning. I called it Playing with the Agent. And it's doing some really interesting stuff. I asked it to, the original prompt that I gave it was that I was giving a live talk and I wanted to demonstrate its capabilities. And so it came up with some ideas about how to do that, scraping data off of a website and doing all kind of stuff. And so here it gave me its plan. And then I said, okay, but choose something specific. It's too general, and so it kind of altered its plan. And then I said, okay, but make sure you do this, and so on. So there's some really cool stuff going on there. So definitely stay tuned because there's some cool stuff happening on the AI agent side that'll be game changing. So that is the end of what I was prepared to talk about.